Today we're going to take a look at Solving Rational Equations Lesson 8. So I'd like you to pause the video for a moment and try the do now, and then turn it back on so we can go over it. So looking at this do now problem, I see that I have two fractions that have the same denominator. So if we think back to our do now, or it might have been the first question on lesson 7, we had a similar setup. We were able to add one of our fractions to the other side. And this allowed me to get one single fraction on the left side of the equal sign, the 3x over x minus 5. And then another single fraction, if I here add x over x plus 3 to 2 over x plus 3, I have a common denominator of x plus 3, and then the numerator would be the x and the plus 2. So now I also have a single fraction on the right side of my equation. I'm able now to cross multiply because I have this one fraction equal to one fraction set up. On one side of my equal sign, I'm going to be multiplying x minus 5 and x plus 2. And that's going to be equal to the 3x times x plus 3. So I'm going to do some distributing. I get x squared plus 2x minus 5x minus 10 is equal to 3x squared plus 9x. Now, because I have a quadratic, which means my highest power is a 2, I'm going to want to get this equal to 0. So I'm going to subtract my x squared to this side. We might want to combine like terms first, but you can subtract the 2x and add the 5x. Subtract the 2x, add the 5x to that 9x, and then add over the 10. All right, so I'm moving all my terms from the left side over to the right side. I have 3x squared minus x squared would be 2x squared. 9x minus 2x would be 7x. 7x plus 5x would be 12x plus 10. I can divide the entire equation by 2 because everything is even. So I get 0 divided by 2 is 0. 2x squared divided by 2 is x squared. 12x divided by 2 is 6x. 10 divided by 2 is 5. I'm just going to continue this over here. So I have x squared plus 6x plus 5. What multiplies to 5 and adds to 6 would be 5 and 1. Oops. So that would be x plus 5 and x plus 1. These two factors are set equal to 0, so I'm just going to tee up my two factors, set them equal to 0 individually, and solve for x. And then just to circle back for a moment to my original equation, in my original equation, I had a denominator of x minus 5, which means x cannot be positive 5. That's an undefined value of x, would make the denominator equal to 0. And I have a denominator of x plus 3, which means x is also not able to be negative 3. That's another undefined value. So if I compare these undefined values to my answers, I can see that I don't have a positive 5 or a negative 3, so I can keep both of my answers of negative 5 and negative 1. Now, in lesson 7, we didn't really take this approach of using cross multiplication each time we went about it. We were coming up with a common denominator. So now just to show you this question again before we try number 2, or number 1 in your notes, I would like to show you this question really alongside here, going over it by LCD so we review that method. So I'm going to rewrite this equation for a moment. And then after reviewing this process, we'll be able to continue on with today's lesson. So if I were to think about an LCD here, same problem, we already know the answer, but let's just approach it the other way. I would be looking at all of my denominator factors. I have a factor of x minus 5. I have a factor of x plus 3. I just happen to have 2 of them. So in my LCD, I just need to make sure that I account for all the factors. So my LCD would be x minus 5 and x plus 3. So when I come back to this first term, I would be multiplying by x plus 3 in the denominator and x plus 3 in the numerator to keep this term equal and to also create the common denominator that I'd like. In my second term, I'm going to do the same thing but with the x minus 5 factor. And in my last term, I'm going to do the same thing but with the x minus 5 factor as well. I'm going to cross out my denominators now that they're all the same. And I'm going to simplify by rewriting the numerators and then taking a step to multiply and combine like terms. So I have 3x times x plus 3. That's going to be 3x squared plus 9x. And then I'm distributing this negative 2. So negative 2x plus 10 equals x squared minus 5x. This one's just a little bit different in terms of like the way the terms ended up because we went about solving this slightly differently than our last problem, but we should end up with the same standard form quadratic of 2x squared plus 12x plus 10 equals 0. And then from there, the steps would be the same as what we did down here. And we would end up with the same answers of -5 and -1. So the LCD approach is what we're going to use more often if you have common denominators in your original problem and want to try to combine terms so you can cross multiply. When that option is available to you, it's also a great method to choose. Okay, the next problem. We're looking at a fractional equation. We're being told we need to solve for x. I want you to, for a moment, just think about what the LCD, we're going to use that approach here, would be for this example. So maybe pause the video for a second and think about it, or maybe try to even write it out. So as you look at this, if you were having a little difficulty, or if you were thinking that there were multiple factors, more than just 2 in your LCD, I want to help you kind of get a different visual of this problem. So first thing I notice here is that I have x squared minus 9, which is something that can be factored further. So I'm going to take this term here, 4 over x squared minus 9, and rewrite it as 4 over x plus 3 and x minus 3. Now I can see that I have already a common factor of x plus 3, right? I have that here and down there. So that's definitely going to be in my LCD. And then I see I have an x minus 3 and a 3 minus x. So the temptation here might be to include both of them because they're not the same, which you're correct. They're not the same. But I know, and we know from simplifying, that opposite order subtraction is almost the same. The difference is that it has a factor of -1 that separates them from being equal. So not that they're the same, but they can cancel and reduce to a factor of -1, which means that I'm going to take this middle fraction right now, and I'm going to multiply it by -1 over -1, right? We're always allowed to multiply by something over itself because really that's just equivalent to 1. And you can always multiply by 1. I'm going to rewrite the first term, and then I'm going to think about what would happen here. So this -1 up here is going to multiply with the 2, make it a -2, right? So I'll put the minus here, that's -2. And then this -1 down here is going to make this initially into a -3 plus x, which if I swap their order, there's my x minus 3. Okay. We also have a double negative here with the -2. So I'm just going to rewrite this one more time just to really show you and also get this to look a little neater. We're subtracting a negative, so I'm just going to make that a plus. 2 over x minus 3 equals 4 over x plus 3, x minus 3. And now I can say that I only need 2 factors in my LCD, x plus 3 and x minus 3. So now let's come back to the first term. I'm going to multiply by x minus 3 over x minus 3. Middle term, x plus 3 over x plus 3. And I shouldn't need to do anything to that last term because it already has it. I'm just going to cross out the first, cross out my denominators, and I only had to change the numerators in my first 2 terms. So now I have 1 times x minus 3 plus 2 times x plus 3 equals 4. the 1, if you distribute it, that's not going to do anything. That's just going to be x minus 3. If we distribute the 2, we get 2x plus 6 equals 4. Notice this equation is not quadratic. The highest exponent of x is just a 1. So I'm going to combine like terms. I get 3x minus 3 and plus 6 is plus 3 equals 4. I'm going to subtract the 3 over 3x equals 1, and I'm going to divide by 3. And I'm going to go back to my original problem real quick just to make sure that this answer seems okay to keep. Both of my denominators, the x plus 3 and the x minus 3, cannot allow x to be either positive or negative 3, but we got 1/3, so that answer is acceptable to keep. I don't have any extraneous roots for question number 1. Okay, and now we're going to try one more together. And then you'll have some time to practice, and the practice answers are at the end of the questions in your packet. So for number 2, we're given this rational equation. And if you notice, this rational equation is also considered a literal equation because it has several variables in the problem. But our goal is going to be to solve for one of them. So let's look through this question. The focal length f of a camera's lens is related to the distance of the object from the lens, J, and the distance to the image area in the camera, W, by the formula below. So we have 1 over J plus 1 over W equals 1 over F. When this equation is solved for J in terms of F and W, so all that means is we want to solve for J, and when we get our equation, in our equation, F and W will be somewhere in there, right? That's all that means. I don't know exactly at this point what they'll look like, but that's what that means. They want us to solve for J. So let's think. We want to identify an LCD. Take a moment to look at this equation, look at the denominators that you have, and see if you can identify that. And if you were thinking J, W, F, you were correct because we have a denominator of J, W, and F. And we need to include all of our original factors into our LCD. So if the first fraction has a J, it needs the W and the F in the top and the bottom. The second term has W, so it needs the J and the F in the top and the bottom. And then the last term has the F, so it needs the J and the W, top and the bottom. So now we're going to cross out the bottoms. I'm going to rewrite the top. So I have WF plus JF equals JW. And again, let's remind ourselves we're trying to solve for J. And right now I see J in 2 different terms. So what we're going to do is we're going to try to get J to one side of the equation, right? We can't solve for something if we don't even have it on one side of our equation. So WF can stay on the left. Now we have at equal to JW minus JF. And if I'm trying to solve for J, I need to get it by itself. Currently, I have it in these 2 terms as a common factor. I want you to think for a moment about what you would need to do to get J out of both of these terms. We need to undistribute it, which really means we need to factor it out because it is a common factor, GCF factoring. And now that J is factored out of those 2 terms, I can take that factor, W minus F, and divide it to the other side. So J is equal to the product of W and F over W minus F. Let's look at our choices. I see the W minus F in choice 2. And if you look at the numerator, they wrote F times W, but with multiplication, you can always change the order. So WF and FW are the same thing. So choice 2 would be our final answer. I hope this video was helpful going over rational equations. Please revisit it at any point if you need a little refresher on the steps and what to think about. There are practice questions in your notes packet, and what I'd like you to do is, give them a try. There's 4 of them, and the answers are at the bottom for you. And then homework 8 would be tonight's homework. Thank you so much for watching.